Okay, so with this warm-up, hopefully you guys saw that you should have had a few issues with the first problem. And there is a reason for that. So, there's a problem with problem number 1. There's an issue. What is the issue? Yes. Yeah, look at this. Angle B is definitely the largest angle. The side opposite is supposed to be the largest side. Is it? No. So that is actually not possible to do. So when you work through your problem number 1, you should have gotten a really loud, angry error message. It's because it's not possible to do that triangle. And if you're paying attention, like Brock was doing awesome, he saw it before he even got started. He was like, wait a minute, that can't be. And that's true. We are going to have cases today. We're going to be exploring what happens. Can I have no triangles possible? Is it just one triangle? Or in some cases, there are going to be 2 triangles possible. In problem number 2, take a look at your answers. You have to start with your angle side pair, but you can easily find your missing angles, law of sines, and finish it off. Now, problem number 1 was special because it didn't work. Problem 2, we're going to come back a little bit later and show you actually have 2 triangles possible there. And we're going to talk about that. But this is all I expected you to do. Okay? Questions on that one? No? Law of sines, nice. Happy, happy, joy, joy. And then there's your picture. And usually it's drawing the pictures that cause the most issues. So what you need to know, and I'm still seeing issues on this from your quizzes, angle of elevation, angle of depression, always find your flat. Tuck your angle in there. Now we're trying to get to this height. So I have to start by solving for either this side here or this side here. So if I kind of ignore what's going on, if I want to find x, that's my angle side pair. That's the one I already have. So I set up my proportion, I find x. I can do the same thing with y. It doesn't matter which one you do. You do not have to do both of them. Once you find one of them, let's say I found my x. Since I'm looking for the height of this thing, I'm just going to look at the part of the triangle that I know about, which is I know that's a 25-degree angle. We were able to find x because it was 70.924. And so if I have this one, I'm looking for this one. Which trig ratio is that? Not cosine. Opposite and hypotenuse. So you would use sine. So you'd set up. You'd say the sine of 25 is the opposite, which is what I'm looking for, over the hypotenuse, which I'd previously found. Or you could take it from the other side and say, oh, look, opposite hypotenuse. It's still sine, but now I'm going to use what I found for y to get that. And in either case, you should come up with z to be 29.974 feet. Because when there are words, you give me words or labels or something. Okay, how's that? All right. So were there any homework questions? Questions from the homework? Yes, ma'am. Number 41, the height of the airplane. That problem is actually very similar to what we just did for number 3 for the warm-up. Sebastian, again, could I get you to close the door? Thank you. So when we go through and we do this, for 41, they were kind enough to draw the picture for us. So we have a helicopter up in the air. So there's my right angle. I have that this is 40 degrees, and the other one is 35 degrees. And the whole thing between them is 1,000 feet. And our goal is to figure out how high the airplane is. So that's what I'm looking for. And when you have a problem like this, basically the steps are always going to be the same thing. You're going to start by looking at your non-right triangle, your whole shebang. And I've got a 40-degree angle, a 35-degree angle. What is that going to leave me for that up there? $105. Good. So that angle up on top is 105, which gives me my angle side pair. So I'm going to say 1,000 over the sine of 105 and pick a side. Do you want the left side or the right side? It's your choice. You want to do the left? Okay. So I'm going to call that y. So I'm going to do y over the sine of 35. And then it's just a matter of grabbing your calculator. So I would do 1,000 times the sine of 35. Make sure you close those parentheses. Divided by the sine of 105. And so I get that y piece is 593.810. And again, we are only rounding to write it down. That whole number is staying in my calculator. So now that I have found this piece here, I want to find this piece here. I'm going to use that right triangle. So this section here is the 593.810. This is what I'm looking for. If I've got a right triangle, which trig ratio am I going to use? Sine. So I have opposite over hypotenuse. So I will say the sine of 40 degrees is opposite over hypotenuse. And therefore, I'm just going to do that number, times the sine of 40. And so I get that height then is going to be 381.694, and we were measuring this in feet. Okay? And you could have done it finding this piece. It really doesn't matter. You would just, what would have changed is your opposite angle here would have changed, and then this angle would have changed. Okay. Other homework questions? Yes? Okay, so 43, hey, at least they didn't give you bearings, right? At least there's no bearings. They gave you a picture. And it says we have, that is not what the picture looks like at all. That's okay. So I'm just going to do A, B, C. And we have this angle coming off the side here of 40 degrees. I have this, this length here is 300 miles. And then this down here is 150 miles. So what we're trying to do here is the distance between, find the distance from B to C. So I'm looking for this, and that's going to be my first piece. So if I'm looking for that, let's start filling this in. If that side is 40, what is this side over here? 140, because they're supplementary angles. They add to 180. So this is going to give me an angle side pair that I can use to solve my triangle. So I'm going to say 300 over the sine of 140. The problem here is I can't go directly to x because I don't know what a is. So I have to kind of work with what I've got. So I have this one. I'm going to start by finding that angle right there. So I'm going to say is 150 over the sine of y so that I can get my angle. So in my calculator, I do 150 sine of 140, close parenthesis, divided by 300, enter, and I'm going to do the inverse sine of that. So my angle here is 18.747. And if that's that angle, can I figure out what this angle down here is? Yeah, so I'm going to take 180 minus that guy, minus the 150 that I already knew about. And so that means that, no, it's not 150, sorry, 140. pulled my numbers from the wrong spot. And so I'm going to get 21.253 degrees. And that now gives me my angle side pair. So I will just set up with my given information again. 300 divided by the sine of 140 is equal to, and in this case I'm looking for x, and I have my y, my angle. I'm going to say the sine of 21.5253, sorry. So let's do this. 300 times the sine of that number, close it, divided by the sine of 140. So I get that distance is 169.177, and we're measuring it in miles. Now for the second part of the question, it says, I'm flying from B to C. That means my plane is going like this. It's going that way. I want to know what kind of an angle I have to turn to go back to A. That angle is 18.747. What do I do to find that angle? Subtract it from 180. And that's it. So I still have that number up in here, so I'm going to go to 180 minus, there it is. And so I get the angle that we have to travel through is going to be 161.253 degrees. Because you're talking about what direction does the airplane have to turn? My airplane is going this way, and then he has to turn this way. Okay? Real quick. Uh-huh. I'm looking. What do you mean convert miles per hour to? Well, you have the distance. You're traveling at 200 miles per hour, so you just divide by 200. How many hours does it take you? Okay? All right, so what we're going to do today, I'm so glad we have almost everybody here as long as Sebastian's awake. Sebastian. Hi. Come back to us. So we are going to be starting some interesting things. We're still sticking with the law of sines. So you are going to have a quiz next class over the law of sines, and that's not changing. But we're kind of opening up what's possible. And the reason that where this comes from, is like if we go back to the problem that I gave you. And in the beginning, when we were solving that, we found 51.486. Right? That was my first angle I found. So I'm going to write that down. 51.486. I want you, and we'll just use those decimals. We don't need to do anything else. I want you to figure out what 180 minus the 51.486 is going to give you. Figure out what that is. What is 180 minus 51.486? 128.514. Okay, now, everybody should have that in their calculators. I want you to find the sine of 51.486, and I want you to find the sine of 128.514. See what you get for those two values. What is the sine of 51.486? Just to 3 decimals. 0.782. What was the sine of the other one? The exact same thing. This is why we have something called the law of sines, the ambiguous case. Ambiguous just means not clear. And that's because if I'm taking the sine, there are actually going to be 2 angles that give me the same value for the sine. So we have to be careful to check to see if there's two answers or just one. So with the first problem that we had, that second problem, on the warm-up, we actually could have had two separate triangles for this. And so that's what we're going to be focusing on today. How do I determine which situation I'm in? So you don't need to copy this down. I just want you to kind of follow along, understand some of the justification. It makes it a little easier to work through this. So I'm starting with a couple of things set in stone. Set in stone is that length. It's 8 centimeters. I'm not going to change it. Set in stone is the fact that I have an angle here. I don't know how long that's going to go out. It's going to stop eventually, but I don't know what it is. And we're going to be talking about the side opposite that angle. So let's go for an easy situation. An easy situation would have been if I could just draw a right angle and make that a right triangle. And I could think about that as a height. Which trig ratio would you use to solve that? Sine. So I would say the sine of 40 is the opposite, which is that guy, over the hypotenuse, which is 8. And how would you solve that? 8 sine 40. So you know what? We're just going to be using this for reference. So if you could just give me that to the nearest tenth. I'm just going to use the number. So I'm just going to use 5.1, just to be easy. So this guy here is 5.1. So far, so good? Now, this is set and this is set. I am going to be giving you, for your problem, another piece that's going to be swinging out here someplace. I'm going to give you a set length that you don't quite know what it is yet. If I gave you a length, and let's say I called that length, I said that this guy over here was 4. That thing is 4. What does that mean? It's not possible because that 4 is just dangling out there. It's not really going anywhere. That 4 is kind of like a pendulum now. It's just going to swing back and forth. No matter where I position that side, it's not going to make a triangle. Does that make sense? If this guy is just 4, it's not long enough because the height here, the shortest distance between two things is a perpendicular line. So I cannot reach from here to here if it's just 4, if that guy is 5.1. Now, let's say instead of having a set of 4, I did a set of 6. That could make a triangle, right? Is that the only place that 6 could go? No, because again, it's like a pendulum. I can grab that and spin it over onto this side and have the same length, that also being 6, but a completely different setup. So this angle is the same for both of those. This side is the same for both of us, and this side is the same for both. That's 6 in both of those cases. So there's actually 2 separate triangles possible. And that happens when we go through law of sines, where we're going to see that these 2 angles will have the exact same sign. What about 7? How many triangles could I make if my length was 7? 2. So if I do 7, I still have my option for 2 triangles. So that would swing over here. And I could have 7 go either way. If that opposite side was 8, how many triangles can I make if that opposite side is 8? Just 1, because can I make a triangle over here if it's 8? No, it'd be just on the same thing. So the only place that it can go if it's 8 is going to be if I take this length and now I move it over here. So with 8, I only have one choice. Does that make sense? What happens if I wanted that opposite side to be 9? If that opposite side was 9, how many triangles could I make? Just 1. Because if I were to do anything bigger than 8, it would have to go out here in order for us to get anything bigger. And you can see I could keep going. There's no limit to how big I can make that side. But the law of sines comes from the fact that if I can find the height of this, I can tell just by looking at how big this adjacent side is and the opposite side is to determine how many triangles I have. So here we go. When you have the law of sines, the ambiguous case is when you have two sides and an angle that is not between them. So we have an angle side pair. So this only happens when you have just one angle. If I give you two angles, there's no choice. The third angle is going to be what it is. There's not going to be multiple decisions for that. It's just one angle. Or one angle possible. If I give you two sides in an angle, we've got to be careful. So the first thing that you do is you find the height. And to do that, you're going to say, this is my angle. This is the height. This is the hypotenuse. So what uses opposite and hypotenuse? Sine. So I'm going to say the sine of my angle is the opposite over the hypotenuse. So if I want to solve for the height is going to be b times the sine of a. And I want you to notice something. Are those the same? Is that the same letter? No. So as long as your angle and your side are not pairs, you're okay. Because understand, if I'm talking about a triangle, if I have A, B, C, A is going to be the opposite side, and both of these two are adjacent. Both of those share a side. So how does this work? And guys, if you're having trouble staying awake, stand in the back of the class. You do not want to sleep through today. Bad day to do that. So the first thing that you do is you start by finding your height. That is always your first step. See, a lot of people haven't written a single thing down yet. You want to be writing this down. I shouldn't have to spell it out for you. So your first step is going to be to find the height. And you are just going to use h equals b sine a to do that. That is going to be your first step. Once you've done that, then the second step is going to be to compare. And specifically what we're going to compare is we're going to compare the opposite and the height. Now, if the opposite is equal to the height, that's my right triangle situation. Only one triangle is possible, and that's actually going to be a right triangle. If your opposite is equal to your height, you only have one triangle possible. Now, if we go back and look at this picture, if the opposite side is shorter than the height, what do we have? No triangles. So a triangle is not possible. So comparing our height and our opposite, we start to figure out how many triangles could I possibly have. Now, the next instance, we said, okay, what if it's bigger than the height? Well, if your opposite is bigger than the height, then you're going to have two choices. You're either going to have one or two triangles possible. And if you fit into that category, your third step is going to be to compare the opposite and the adjacent. If your opposite is less than the adjacent, that's when we could have two triangles. whereas the opposite is bigger than the adjacent, you're only going to have one triangle. I know, that's a lot of stuff to try to kind of memorize. If you're good at memorizing, this is going to be easy then. If you're not so good at memorizing, I'm going to show you how it will work out anyway. But no matter what, I need you to have this in your brain. And if you can't memorize it, you've got to be able to know how to find that the height of your triangle is b times the sine of the angle. Okay? So even if you're going through all of this going, what the heck is she talking about? You need to be able to do that. All right. So we're going to do a problem. Now again, I don't need to draw the picture for this. All I need to do is kind of list out what I have. I'm going to have angle A, angle B, angle C, side A, side B, side C. Where I'm told angle A is 120 degrees, side A is 45, side B is 36. Okay? That's my first piece of information that I'm given. So what is my first step to do here? Find the height. So my height is going to be B sine A. Or because you're going to have different angles going on here, your angle and the side that does not pair up with it. Does that make sense? Because either this one or this one will both be adjacent. So the angle and its non-paired side. So I'm going to take 36 times the sine of my angle. And we're just using this for comparison's sake. So just take it to the nearest tenth and tell me what you get. 31.2. So the first step was to find the height. We did that. The second step is to compare the opposite side to the height. Now the height we just said was 31.2. How big is the opposite side? That's not the opposite. 45. Angle and its opposite side, that's the pair. So the opposite side is 45. So if I'm thinking about the opposite and the hypotenuse, the opposite is what the hypotenuse? It's bigger than the hypotenuse. The opposite is bigger than the hypotenuse. And if the opposite is bigger than the hypotenuse, then what's true? I'm going to have one or two triangles, and I have to figure out which one that's going to be. So to figure out which one that's going to be, I'm going to compare this time the opposite to the adjacent. So my opposite was 45. What's my adjacent? 36. What symbol goes between here? Greater than. And if the opposite is greater than the adjacent, how many triangles do we have? One. All that information to just say, hey, guess what? Now you're going to do the law of sines just like you always did. So I want you to go through the law of sines, and I want you to solve for angle B, angle C, and side C. Let's go ahead and check our answers. Here we go. Should have come up with, I don't know why the lighting is weird on that. Should have come up with 43.854 degrees for B, 16.146 degrees for C, and 14.450 for side C. How are we doing on that? Okay. So if you remember your rules, that lets me know right away exactly how many triangles I have and what type of situation you've got going on. Now let's say you're like me. I can't memorize things to save my soul. I'm lucky I know my name after all of these, 26 years? Because, right, I'm 26 years old. Wink, wink, nudge, nudge. Yeah. No. Trying to make a joke and nobody cares. Okay, so what we can do here, the kind of a standard just smack it with a trig stick rule until something comes out is this. So we have A is 120 degrees, side A is 45, side B is 36. So we know that we're probably going to have a triangle. And if it gets an error message when I start and try to find this guy, well, then I know that there isn't a triangle. But what I can also do is I can start the setup as if I have two triangles. And for this, our given information still stays exactly the same. And you're still going to solve it the same way we did before, where we're going to find this guy using the exact same methods, using the 45 over the sine of 120 is 36 over the sine of B. And just like before, we get B to be 43.854. You guys ready? Because no matter what, this is how you're going to handle it when you have two triangles. Everybody paying attention here? This is huge. Okay, so this is what I found first. What I'm automatically going to do is I'm going to do 180 minus that angle. So can somebody tell me what 180 minus 43.854 gives me? $136.146. If I had a second triangle, that is how you would find your angle. Now here's my question. I have 120 degrees. I have 136 degrees. Can I make a triangle with that? Why not? So how many degrees do we have? 180. That just broke my triangle. So I know it's just one triangle because if I try to do the other one, it doesn't work. If I do 180 minus this, I'm going to get some weird thing. We don't do that. Okay? So no matter what, that's going to be the steps that we'll take when we have two triangles. So let's write down this information. This is your new triangle. Capital letters are your angles. Lowercase letters are your sides. Okay? Why did I do it over there? I like writing them side by side. And see, my pair is easier that way. Come on, Ogs. 186.2, 248.6. Okay. So as before, what did we say our first step was? Find the height. So in order to find the height in this case, I'm going to do what times what? B sine A. I don't have angle A this time though. Yes. The non-paired side. So I will say the 248.6 times the sine of 43.1. And really here, we're just using this for reference, so take it out to the nearest tenth, so we kind of know what we're dealing with. What'd you get? Beautiful. 169.9. And we're going to use that to compare, firstly, the opposite against the height. So what is my opposite side here? Is it B or is it C? One more time. It's B because that's your pair. So my opposite is the 186.2. What sign goes in between? Greater than. And so it's greater than, what does that tell me? Huh? One triangle? One or two? And since I'm not sure which one, now I go and I compare the opposite to the adjacent. 186.2. And the adjacent is then 248.6. What symbol do I have here? Less than. And if it's less than, how many triangles? 2. So what I'm going to do is I'm going to go ahead and I'm going to set up a second triangle. Where the given information stays exactly the same. Yay! 2 problems for the price of 1. Isn't that generous? Okay. Well, now it's just the law of sines. So what I'm going to do, and I'm just going to number these so you know where I'm going with this. I'm going to find this first. Okay, and I'm going to do that with my law of sines simply by saying, let's see here, my given stuff that pairs up, I'm going to do 186.2 over the sine of 43.1. That's going to be equal to 248.6 over the sine of C. So I need you guys to go through and find me what your angle C is going to be. So you're actually typing stuff in here. You guys get what C was? 65.819. So that goes here. And as soon as you find that one, your very first angle, stop. Go over to the other triangle. Find the other angle that this could be. How do I find the other angle that that could be? Yep, 180 minus that. So what do you come up with? Simple state, 180 minus this. What do you get? 114.181. So that goes here. So far, so good? Basically, at this point in time, we now just have 2 completely separate problems. So if I ignore this, what would I need to do to solve this triangle? Yes, 180 minus both of those. And can you tell me what you get from that? Starts with a 2, I'll give you that. $180 minus 43.1 minus that 65.819 that should still be in your calculator. What do you get? Oh, I said the wrong one. Sorry, I was looking at the wrong problem. That's why everyone was confused. 71.081. Finish that triangle off. Do the same thing for the second triangle. Find the third angle, finish the triangle off. Let's take a look at what we should have gotten. I'm going to zoom in so you can see. And what do you think? How do we do? Good? Yes. This one? So we had already found these two. How many degrees are there in a triangle? That's okay. Yeah. How did I get what? I used the same thing that I did up here. I used angle side pair. And then I said A over the sine of that angle that I found. Exact same thing as what you did above. Yes? Yeah, I forgot to write down what the last two digits were. Could you tell me what the last two digits were? 0.790. Thank you. I was hoping somebody would remind me about that. Okay, anybody else? So the big difference here, once we identify the fact that we have two triangles, you're going to find one angle to start with, immediately subtract it from 180 to get the other angle. And then basically now we work it like two completely separate problems. So I want you guys, let's start number 3. And then I'm going to give you guys some practice. TJ. Come on. Pay attention. Wake up. And that's a capital C just so you can tell there. What am I going to do first? Find the height. So for the height, I'm going to say the height is something times what? Something, what is my something? That's not a degree. So it's going to be 122. And then sine of 42. Just give it to me the nearest tenth because we're just going to be using it to compare. 81.6. Thank you, sir. So that's my height. So now I need to compare my opposite to my height. Which number is my opposite? 70. What sign goes between those two? Less than. So that tells me what? How many triangles? No triangle possible. We can't do it. And you know what? Even if you didn't notice that, could you have gotten the same answer? Absolutely, because you would have done 70 over the sine of 42 is 122 over the sine of b. And if you were to go through and try to solve that, you would have done 122 times the sine of 42 divided by 70. And then inverse sine of that, my calculator will start to scream at me. See, my calculator is screaming at me. That also tells me no triangle is possible. Okay? So basically, it's just a little bit added on to what we were talking about with regular law of sines.